1963, Chevrolet showed up to Daytona with an engine nobody had ever seen before. No press release, no factory announcement, no name. It ran 10 miles per hour faster than anything else on the track. When reporters asked Chevy what it was, the company said nothing. Literally nothing. As far as Chevrolet was concerned, the engine did not exist. They called it the mystery motor. And the real mystery wasn't the engine itself. It was how Chevrolet got it past NASCAR's inspectors when, by the rules, it shouldn't have been there at all. To understand why Chevrolet needed a secret weapon in early 1963, you have to understand what the company was up against. Ford had just pulled out of the Automobile Manufacturers Association agreement, the gentleman's handshake from 1957, where the Big Three promised to stop racing. Henry Ford II basically said, "We're done pretending," and announced a total performance campaign. Factory-backed Fords were showing up at every track in America with real engineering support, real money, and real intent to win. Chrysler wasn't far behind. They had a 426 wedge engine that was competitive and were quietly developing something far more dangerous, a hemispherical combustion chamber design that would debut in 1964 as the legendary Hemi. Everyone in the industry knew it was coming. Pontiac, GM's performance division, was winning everything in sight with their Super Duty 421 engines. But Pontiac was a different division with different management. Chevy, the volume brand, the one that actually mattered to GM's bottom line, was falling behind. And then there was General Motors as a whole, the biggest automaker on the planet, controlling roughly half the American car market. And that was precisely the problem. GM's leadership was terrified of the federal government. When you own half the market, the Justice Department's antitrust division starts paying attention. GM's chairman, Frederick Donner, was a finance man, not a car guy. His primary concern was keeping the corporation intact, not winning races. So while Ford and Chrysler were gearing up for war, GM was officially still honoring the AMA ban. No factory racing support, period. But Chevrolet had a back door. It always did. Since the late 1950s, a man named Vince Piggins had been quietly running performance operations for the Bowtie brand. Piggins was a former Hudson racing engineer who understood something fundamental about the car business. You win on Sunday, you sell on Monday. He'd already helped create the Black Widow program in 1957, turning stripped-down Chevy 150s into NASCAR dominators through a front company called Sedco, run out of a Chevrolet dealership in Atlanta. When GM officially killed SEDCO, Piggins just moved the operation further underground. By 1962, Chevrolet's frontline weapon was the 409, a decent engine, popular enough that the Beach Boys wrote a song about it. But popular and competitive are two different things. On the high-banked superspeedways like Daytona, Charlotte, and Atlanta, the 409 was running out of breath. The W-Series architecture that underpinned it had a fundamental limitation, and it started with the cylinder heads. The W-Series got its name from the W-shaped valve covers. The combustion chamber was machined into the block at 74 degrees rather than the standard 90. This unusual angle meant the chamber geometry was dictated more by manufacturing convenience than by what the air actually wanted to do. At street speeds and even moderate racing speeds, it worked fine. The 409 made honest power and decent torque. But at sustained high RPM, the kind you need to hold 165 on Daytona's 31-degree banking lap after lap, the chamber shape choked airflow. The valves couldn't breathe fast enough to keep up with the engine's appetite for fuel and air. The 409 had topped out around 425 horsepower in its most aggressive tune. Ford's 427 was making similar power, but doing it more efficiently at high RPM. The 409 was maxed out. Engineering knew it, management knew it, and Ford was pulling away. Chevrolet needed something fundamentally different. Not a bigger 409, not more cubic inches stuffed into the same architecture. They needed a new way of thinking about how air moves through a cylinder head. The man who would solve this problem was an engineer named Dick Keinath. Quiet, methodical. The kind of guy who'd held every job in Chevrolet's engine group, from draftsman to chief engineer. He'd worked on the original small block with Ed Cole. He'd developed the 348 and 409 cylinder heads. If anyone understood the limitations of the W series, it was Keinath. Sometime around 1960, possibly earlier, Keinath started sketching something new. The idea was deceptively simple. Instead of having the intake and exhaust valves sitting upright and parallel in the cylinder head, like every other wedge engine, you'd tilt them, cant them at different angles so that each valve opened away from the combustion chamber walls and away from the cylinder bore. The intake valve would lean toward the intake port. The exhaust valve would lean toward the exhaust port, each one getting out of its own way, unshrouding itself as it opened. When you looked at the assembled head from above, the valve stems pointed in all different directions, like quills on a porcupine. That's exactly what people called it, the porcupine head. Officially, Chevrolet called them canted-valve heads. Unofficially, they called the whole engine the Mark II. Keinath didn't have computer-aided design, no computational fluid dynamics, no simulation software. He had slide rules, drafting tables, and a deep understanding of how gases behave inside metal passages. And what he designed, without any of those modern tools, would become the foundation for every big block Chevrolet built for the next 3 decades. Development was conducted in secret, not just secret from the public, secret from most of GM. To keep the project off the radar, testing moved to GM's winter proving ground in Mesa, Arizona, rather than the usual facility in Milford, Michigan. Salmon Bunky Knudsen, who'd moved from Pontiac to head Chevrolet in 1961, gave Keinath a blank check. Knudsen was a car guy. He understood what was at stake. By August of 1962, Piggins was circulating internal memos. 2 new engine programs were being fast-tracked. The Mark I was essentially a bored-out 409, designated the Z11, intended for drag racing. The Mark II was something else entirely. A clean-sheet racing engine designed specifically for NASCAR's superspeedways. Initially, it displaced 409 cubic inches, same as the existing engine. But in October of '62, after what multiple sources describe as political negotiating with NASCAR, the displacement was bumped to 427 cubic inches. New stroker crankshaft, new rods, new pistons. The 427 was born. The plan called for 20 Mark II engines to be built for NASCAR, only 20. NASCAR's rules at the time required that an engine be available in sufficient production quantities to qualify as a stock component. The generally accepted number was 50. Chevrolet claimed to have produced components for 50 engines. The reality was considerably murkier. In November of '62, the engineering team traveled to Mesa for back-to-back testing. They put a race-prepped 409 Impala against an identical car fitted with the new mystery motor. According to Bill Howell, one of the Chevrolet engineers present, the difference was immediately obvious. The new engine was good for about 10 more miles per hour on the high-speed oval. A massive advantage. By late '62, engines started shipping to the teams Chevrolet trusted most. Smokey Yunick in Daytona Beach, the man who ran what he called the best damn garage in town. Ray Fox and his driver Junior Johnson, a former moonshine runner from North Carolina who'd already won the 1960 Daytona 500 by inventing the draft. And 1960 Grand National champion Rex White and his crew chief Louis Clements, who were actually commissioned by Chevrolet to build the test cars used at Mesa. Here's where the story gets interesting. Actually, here's where the story gets ridiculous. NASCAR required roughly 50 engines to exist for the mystery motor to be legal. Chevrolet's internal memo from Piggins said 20 were built. According to Louis Clements' son Mike, who was there when the GM truck arrived at Smokey Yunick's shop. Only 14 engines rolled off that truck. 14, not 50, not even close. So how did they pass NASCAR inspection? The teams got creative. Smokey Yunick, Rex White, and the other Chevy operations started shuttling engines between their garages. When NASCAR inspectors showed up at one shop, the engines were there. When the inspectors moved to the next shop, the engines moved too. They'd repaint them, change minor cosmetic details, present what appeared to be a different set of engines at each location. One complete mystery motor was even delivered to the Holman Moody Ford team, a gesture of proof that enough engines existed. Bill France, the founder of NASCAR, wasn't stupid. He almost certainly knew what was going on. But Chevrolet had a massive fan base. Chevy fans bought tickets. They watched races. They bought products from sponsors. France looked the other way. February 1963, Daytona Speed Weeks. The mystery motors arrive. Nobody outside Chevrolet's inner circle knew what they were looking at. The engine had distinctive wide valve covers that looked nothing like the familiar 409. Reporters could see it was different. The teams wouldn't say a word. Chevrolet's PR department issued no photos, no technical information, no press materials. The engine officially did not exist. Then qualifying happened. Johnny Rutherford, driving Smokey Yunick's number 13 black and gold Impala, turned a lap at 165.183 miles per hour. That was the fastest qualifying speed at Daytona that year, a closed-course stock car record. For context, Fireball Roberts had won the pole the previous year in a Pontiac at about 157. Rutherford was 8 miles per hour faster in a stock car on a super speedway. In racing, 8 miles per hour difference is not a gap, it's a chasm. Junior Johnson, in Ray Fox's number 3 Holly Farms Impala, was right there with him. During practice laps, Johnson reportedly hit 168. Some sources claim speeds approaching 170 on certain laps. The 409 Chevys from the year before were running around 155. The Fords and Pontiacs were in a similar range. The mystery motor cars were running in a completely different zip code. The paddock was in chaos. Nobody could figure out what Chevrolet had done. The valve covers were wrong. The heads were clearly not 409 heads. But Chevy wasn't talking, not to the press, not to the competition. Ray Brock from Hot Rod magazine was the only journalist who got any cooperation, and even that didn't happen until months later. Rutherford won his 100-mile qualifying race. Johnson won the other one. Rex White finished second in the other qualifier. It was a clean sweep for Chevy in the preliminaries. The Ford and Pontiac teams were stunned. They'd brought guns to a knife fight, and Chevrolet had shown up with a cannon they'd built in secret. And then, just days before the Daytona 500 itself, everything fell apart. GM Chairman Frederick Donner dropped the hammer. A corporate memo went out to every division: no more racing, no exceptions. GM was recommitting to the 1957 AMA ban, effective immediately. All factory support for all racing programs was to cease. Pontiac's Super Duty program killed. Corvette's Grand Sport program killed. And the mystery motor dead on arrival. The timing was devastating. Donner's motivation was almost certainly the antitrust fear. GM was too big, too dominant, and too visible. Racing victories drew attention. Attention drew regulators. Donner wanted GM to be invisible. Some historians point to a speech given by American Motors President Roy Abernethy on January 18, 1963, criticizing automakers for promoting speed and horsepower. Within hours of that speech, GM's executives were in emergency meetings. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. The Chevy teams at Daytona were allowed to race what they had. But there would be no more engines, no replacement parts, no technical support, and no future. The Daytona 500 itself didn't go well for the mystery motor cars. Johnson's ignition failed on lap 26. The G.C. Spencer car's engine let go on lap 95. Rex White struggled. Rutherford soldiered on to a ninth-place finish, 4 laps behind winner Tiny Lund in a Ford. The engines that had dominated qualifying couldn't survive 500 miles of racing without proper development. The block castings had core shift problems. The oiling system wasn't fully sorted. These were prototype race engines, still in their infancy, and they just lost their entire development program. But Junior Johnson wasn't done. He had a mystery motor. He had Ray Fox. And he had nothing to lose. Without factory support, Johnson and Fox carefully managed their handful of engines through the 1963 season. Rex White and Louis Clements eventually gave Johnson their engine to supplement his supply. They picked their races strategically, entering only 33 of the 55 Grand National events that season. When the mystery motor lasted, it won. Johnson took 7 victories, 9 pole positions, 13 top 5 finishes, and 14 top 10 results. At Charlotte Motor Speedway, in front of more than 46,000 fans, Johnson won the National 400. It was the mystery motor's last major victory. Now, the engine itself. Let's talk about what made this thing different. Start with the bore and stroke. 4.31 inches bore, 3.65 inches stroke. Same dimensions as the Z11 drag racing engine, totaling 427 cubic inches. But that's where the similarity ends. Designer Dick Keinath was clear about this. The only component the mystery motor shared with the W Series was the crankshaft. Everything else was new. The block retained the 4.84-inch bore center spacing from the W Series, and the main oil gallery sat in the same location. That was deliberate. Keinath wanted tooling commonality where it didn't compromise performance. But the deck surface was cut at 90 degrees, standard and perpendicular, unlike the W Series' unusual 74-degree angle. This was critical for the new cylinder head design. The heads were the whole point. In a traditional wedge head engine, the intake and exhaust valves sit relatively upright, parallel to each other, separated by a wedge-shaped combustion chamber. It works, but it compromises airflow. As a valve opens, the side closest to the cylinder wall or chamber wall is partially blocked. The gas has to squeeze past the obstruction. At low and moderate engine speeds, this doesn't matter much. At racing RPM, it's a wall. Keinath's canted valve design changed the geometry entirely. The intake valve was tilted toward the intake port. The exhaust valve was tilted toward the exhaust side. Both angled away from the chamber walls. When either valve opened, it moved into clear space. No shrouding, no obstruction. Gas flowed freely around the entire circumference of the valve head. The intake valves measured 2.19 inches in diameter. Exhaust valves were 1.72 inches. These numbers don't sound revolutionary until you realize what they achieved in terms of airflow. Multiple sources claim the heads were nudging 300 cubic feet per minute at 28 inches of water on the flow bench. For 1963, that was staggering. Most factory performance heads of the era were doing 200 to 230. The combustion chamber was what would later be called a closed design, similar to what appeared on the 1965 Mark IV 396. Pop-up pistons gave the mystery motor a 12.4 to 1 compression ratio before any milling. The rocker arm ratio was 1.75 to 1. Screw-in rocker studs replaced press-in units for reliability at high RPM. Each cylinder head weighed 25 pounds less than the later Mark IV production heads. That's 50 pounds less across both heads. Weight savings in the cylinder heads translates directly to a lower center of gravity, because the heads sit at the top of the engine. The intake manifold was a 180-degree high-rise aluminum design. 4 different prototype manifolds were developed and tested. All used a single Holley 4-barrel carburetor. The engine also featured a cowl induction setup using the natural low-pressure area at the base of the windshield to force air into the engine. This was a Chevrolet innovation. NASCAR stockers use a similar principle to this day. The exhaust manifolds were cast iron, standard NASCAR practice for superspeedway racing. 2-inch primary tubes running 33 inches long, dumping into 4-inch diameter collectors 26 inches long. The manifold design was reportedly influenced by header-like flow principles, just packaged in cast iron for durability and rules compliance. Power output is where things get contested. Smokey Yunick and various sources have claimed 620 horsepower on the dyno with the single 4-barrel. Louis Clements's son Mike says the engine his father built for Rex White pulled 540 on the dyno the night before the race. Bill Howell, the Chevrolet engineer who was actually in the room during testing, says the highest numbers he remembers were about 530 to 540 brake horsepower. He considers the 620 figure false. The truth probably sits somewhere in the range of 520 to 580, depending on which manifold, which tune, and which specific engine. Even at the conservative end, that's a massive number for 1963. The 409 in race trim was making somewhere around 425 to 450. The mystery motor was delivering roughly 100 more horsepower from the same displacement, all from better breathing, and it was lighter. Ray Brock, writing in the May 1963 issue of Hot Rod magazine, noted that the mystery motor was about 50 pounds lighter than the Z11 427. Think about that. More power and less weight, from an engine of the same displacement, using the same fuel, running a single carburetor. The entire advantage came from the cylinder head design and the resulting improvements in volumetric efficiency. The bottom end used 2-bolt main bearing caps. This may have contributed to some of the engine failures at the Daytona 500. The block castings also suffered from core shift in the initial production run, a manufacturing defect, where the internal cores that form oil and coolant passages shift during the casting process. These were problems that more development time would have solved. That time never came. So what happened because of all this? In the short term, the mystery motor proved a concept. Canted valves in a relatively compact head package could deliver airflow rivaling hemispherical designs without the complexity, weight, and width penalties of a true Hemi. The heads fit in the engine bay of a full-size Impala with room to spare. More importantly for Chevrolet's long game, they were designed from the start to fit the C2 Corvette, which was launching in 1963. 2 mystery motor-equipped Corvette Stingrays actually competed in the American Challenge Cup at Daytona in February '63, a sports car race held before the 500. Almost nobody noticed at the time. They were the first big block Corvettes ever built. Mickey Thompson was involved. So was Zora Arkus Duntov, Chevrolet's legendary Corvette engineer. The racing ban killed the mystery motor program. But it didn't kill what Keinath had learned. The canted valve principle, the combustion chamber design, the port geometry, all of it fed directly into the Mark IV big block that debuted in 1965 with the 396 and appeared in 427 form in 1966. The Mark IV would go on to become one of the most successful and prolific engine families in automotive history. The 396, the 427, the 454. All descendants of that clandestine project in Mesa, Arizona. Smokey Yunick, true to form, never returned a single mystery motor to GM for disposal. He kept everything. When his first public auction happened in 1986, an astonishing stash of prototype parts surfaced, including pieces from the mystery motor program. Junior Johnson's 1963 Holly Farms Impala, the number 3 car with its original mystery motor still under the hood, survived for over 60 years in near-original condition. It's now part of the RK Motors collection. One of the only surviving examples of a mystery motor that actually won NASCAR races. Ford responded to the mystery motor threat exactly as Hot Rod's Ray Brock predicted. Within a year, Ford had the single overhead cam 427 Cammer, their own radical cylinder head design. Chrysler unleashed the 426 Hemi in 1964. The arms race that the mystery motor helped trigger would define American motorsports for the rest of the decade. In a way, Chevrolet's secret engine fired the starting gun on the entire muscle car era's escalation. And there's an irony buried in this story that's hard to miss. GM killed the mystery motor because they were afraid of government attention. They wanted to seem like a responsible corporation that didn't promote speed. Within 2 years, the Mark IV big block, carrying the mystery motor's DNA, was powering Chevelle, Corvettes, and Impalas on showroom floors across America. The racing ban didn't stop the performance war. It just moved it from the track to the street. John DeLorean and Jim Wengers at Pontiac figured this out almost immediately and created the GTO. Chevrolet followed with big block everything. The very thing Donner tried to prevent, the association of GM with horsepower and speed, became the company's most profitable identity through the rest of the 1960s. The engine that Chevrolet officially said didn't exist ended up influencing every big block V8 the company built for the next 30 years. Dick Keinath, the quiet engineer who designed it all without a computer in sight, eventually went to work for Junior Johnson. He passed away in July of 2010. Multiple sources note that Chevrolet barely acknowledged his passing. The man who fathered the modern big block Chevy died without much fanfare from the company that benefited most from his work. The Mark IV production heads, the ones that went into millions of Corvettes and Chevelles and Camaros, were reportedly not as good as Keinath's original mystery motor heads. Smokey Yunick said the accountants ruined his design. Multiple engine builders have noted that the original Mark II port geometry was superior to what eventually went into production. The manufacturing compromises required to mass-produce the heads diluted what Keinath had achieved in his hand-developed racing originals. Even today, engine builders studying the mystery motor heads remark on how advanced the design was. The exhaust port geometry, in particular, anticipated concepts that GM wouldn't revisit until the LS7 decades later. Keinath, working with slide rules and intuition in 1960, designed ports that modern computational analysis confirms were remarkably efficient. So that's the story. Chevrolet built an engine in secret, smuggled it past NASCAR inspectors with a shell game involving maybe 14 engines pretending to be 50, dominated qualifying at Daytona, then had the whole program killed by their own chairman before the engine could prove what it was truly capable of. The engineering survived, the engine didn't. There's something fitting about the name. The mystery motor. Because more than 60 years later, nobody can fully agree on how many were built, how much power they made, or what might have happened if Frederick Donner had kept his memo to himself for one more season. The answers died with the engineers and the racers who were there. What survived is the engine itself in the handful of examples that Smokey Yunick refused to give back, and in every big block Chevrolet that followed. And there you have it, Chevy's mystery motor. An engine so secret its own company denied it existed. If you've ever seen one in person, or you think I got something wrong, drop it in the comments. And if you made it this far, go ahead and subscribe. We do this every week.